Welcome to our talk. We used to work together at the National Police investigating hackers. And today we're going to talk about a tool we had to make to be able to investigate a hack. So me, Sindre, used to work in the police. I am a police officer and self-taught in programming and all that stuff, transitioned to working at a cybersecurity firm as an analyst. And Åge, my man here, is like the go-to guy at Kripos. So if there's anything related to a computer or internet, he is probably involved in those investigations.
Probably not, but yeah, I work with a small team of developers and people who are close to the investigators in cybercrime cases or other cases. We're trying to fetch information from the internet, structure it, present it, and make it understandable for the investigators.
Yeah. So yeah, our talk today. We'll try to take you from early 2019, when a fairly large company in Norway, Norsk Hydro, was hit by a ransomware attack, and it became a large international investigation. And we're going to talk about when we got that initial investigation of it, we were able to seize some C2 servers of the criminals. And then we found they used Cobalt Strike. And how are we going to look at that data? It's easy if you have one server, but if you have 100 servers, it's a hassle. So we created a small tool. The first version was it's really, really simple. And I got help from Åge at some point, and we made it a bit better. And it has led to multiple arrests, most notably in Ukraine during the war. So yeah, if you're from Norway, you've probably seen this image a couple of times. This is what happened, and this is what all the people working for Hydro saw. And basically, what it says is, Hydro is under attack. Do not connect your computer or phone to any network until further notice. This was like, everything is off, everything's shut down, because they were hit hard with a ransomware attack. So yeah, ransomware, and they were kind enough to be really open with the police and say, okay, come help us and do everything. And we got some IP addresses, and we were able, through partners outside in Europe, to seize those servers or make snapshots of them. So the criminals didn't know we had the data, but we had data. So the ransomware was they used Locker-Goga, Megacortex, all the big ransomware malware was used by this group, and they used Cobalt Strike. So why do they use Cobalt Strike? Because it's easy to use, and the criminals, they basically do the same as pen testers when they get a foothold. And Cobalt Strike is so easy to use. It's basically point and click for some, and they had some pirated versions because you can't go ahead and buy it if you don't have a legit company. So it's a stolen software version. So what we've seen is the one guy that probably hacked or cracked the software. He tested it first at home and used it, and his data from his computer has followed this version all the way, how he tested it initially to see if it worked. So yeah, since Cobalt Strike is a pen test tool, you get a very good report at the end of your engagement. So we could use that, and it logs everything because it's built to log everything and document, and that's good for us. So yeah, we had a couple of C2 servers with Cobalt Strike and Metasploit and stuff like that. So we needed to do get a better way of seeing or using that data.
Yeah. So as Sindre says, Cobalt Strike is used, and it's used in the same way as pen testers use it. So it's primary pen testing tool. So what they do is they set up a team server, which is their hub, They connect to it with a client. And then they start some sort of attack chain. They have a vector infect somebody, phishing typically, and they get a beacon on some poor soul's network, and this beacon calls back to the C2 team server. And the team can be from multiple countries, can be lots of people or just one, doesn't matter. They start sending commands down to the beacon where the foothold is, and then they start pivoting through the network of the attacker, or even through other networks that the victim has access to. So they try to spread as far and wide as possible, and then they set up alternative routes back to the C2 infrastructure. So they go through either relays or other team servers. And for a security person, then you are most of the time you see this side of things. You see the victim side. Somebody has been compromised, and you see the network logs on their side. Now, on the police side, we can get hold of these other servers, and that's when things gets really interesting, and we can start to get a view over how the mode of operation for the attackers are, and how they work, and what kind of groupings are there. Is it this group, or is it that group that attacked this person, or how things are sort of organized. So the team server is basically just a Linux machine running somewhere in the cloud. And most of the time we see them using VPS service like bulletproof hosting or other things. They run a Cobalt Strike server, which is a Java-based product. And this thing has different services that they put up. So you have a web server to deliver payloads. You have a DNS server to sort of either deliver payloads or exfiltrate data out through. Things like that. And it writes, on the server side, writes log files of all the activity that the team that is using the team server is doing. So when somebody logs on the server, this is written to a log file. If somebody starts a command saying, run this on that victim computer over there, this is logged. The result that comes back from the beacon is logged. In addition, it writes a sort of a state of the sort of in-memory database to files. So you have like a snapshot of whatever the server was doing at the time as serialized Java objects, which you can pick apart. And this is the idea that Sindre had, and which we have sort of developed further. So this is how the client looks. This is a Cobalt Strike client, and you see here a list of targets. This is machines inside somebody's network. Local addresses, you can just pick one and say run whatever command on this machine, or set up more elaborate sort of exploration of the service. You can dump Active Directory database. You can do in-memory dump of passwords and so on, trying to extract as much information from the victim as possible. And it's all very handy and well executed. So these are the names of computers and notes that the attackers are putting on the machine. So you can see here that they are saying, yeah, this is the AD server, here's the management, this is the CEO's computer, this is the whatever. If they find important computers, you can see them noted in the list here. So the beacon, which is put inside the victim's network. That is just a small program, or it can be small or big, whatever. But it has the task of executing payloads on behalf of the attacker. So payloads can be parts of tool chains like Metasploit or others. These tools are performing their work and then funneling the results back to the C2 by some means of exfiltration mechanism, either just copying the files directly out, or if it's inside a secure network, you can use all sorts of weird techniques like DNS to exfiltrate data. It's slow, but it works. So
yeah, finding the good stuff. There's a lot of logs, because the tool itself is like one engagement, stop the server, get the report. But these guys, they had like team servers that had been running since early 2018, so over a year running, and they've done multiple different victims, companies, whatever. So they had like a large list of infected machines. I'm not sure how they were able to like have control of what they were doing. And we see that as well, like they're trying passwords on the wrong machine because they didn't have control. Like, oh shit, wrong victim. So basically this is how the logs are, or the initial logs, they're in plain text log file. So this is where we started. We found the logs. Okay, let's read them and see what they're doing. And then we had like, okay, they ran this command at that timestamp. It was this user, whatever. And police officers are doers. So if there's the basic mentality in the police, like if there's 1,000 logs, we need 10 people to read them. It's just divided by people. Give more people, more people, more people. It's like, and one example of that, I got a mail from a colleague in France. He had been sitting over the summer and doing basically the same stuff I was building a tool to do automatically, manually. So his job was basically go in, fire up the VM, create the Cobalt Strike report in a PDF, take the PDF, read it, copy, paste, basically doing it all manually. And he sent me a mail. I don't think you can read it, but it's like you can see his frustration when he heard about me having done what he was doing every day for like half a year automatically. So that's the thing. Yeah, basically he took the image, created, fire up the virtual machine, ran Cobalt Strike, exported the PDF. So yeah, so we started like version 1. I only knew about these logs. Like, okay, there's the log. How do we get it into a spreadsheet? Because police officers love Excel. That's the best tool in the world. You can do everything. So that's what they wanted. So okay, we start like most of you like, okay, we have a file, just bash, awk, split, whatever, get it out. And it works sort of because, and then you go to the, when you see like the output line, then it sort of breaks the format. Okay, how are we handling that? So it was a pain in the ass. And the script was ugly as, yeah, basically it was I made a Python script that did it, and it didn't do it really good, but it did it okay enough. So, and came to a point like there has to be a better way, because the Cobalt Strike makes the PDF report. It has to get this data from somewhere. I'm not like, it can't be the log text files it uses as its source. So where's the data? So we found, so yeah, I'll get to that, but like, so we came like, this program, it works, we need it, and the other police units out in Europe, this is good, we need it. So we had to start the process, okay, if we're going to do it, we need to do it better. So we need better structure. We need to make a plan of the tool and start like a development. So we need, and refactor everything, because the code was, it ran on my computer, basically. And I just made it, okay, what dependencies do I need? And I've tried to run it on a friend's computer, and like, it doesn't work. And we needed to give it an awesome name. So we came up with Cobalt Strike Parser. So, And that is stuck. So it's CSP short internally. So we set ourselves some goals for it, and so the tool should analyze the files inside the CS folder. We need to provide a quick overview for the investigators through Excel and PDF reports, and timelines and all those fancy visualizations. And we had like this idea we could use this to identify the victims, because we saw a lot of computers that had been infected for a long time, where the attackers were ready to deploy ransomware, but they hadn't done it yet. So, okay, we need to actually warn people about it. And that's like the phase of what stages are the victims in. And also identify other C2 servers, because when we had one server, we saw they had listeners to other C2 servers. Okay, then we can go and seize that server, and we get a new one, and we seize that server. And also we were able to like provide an overview of, okay, what data was exfiltrated by the attackers, and how many people are there working and stuff like that.
Yeah, so we stuck with the idea that this should be a Python script, because we are Python programmers. So basically the script works by pointing it at the file in the folder structure. This is the Cobalt Strike folder structure. And we have to sort of peel the layers of this and get all the details out of it. So you get the log files that Sindre was mentioning in a sort of structured, semi-structured format, where each of the beacons have their own logs, and the screenshots are stored somewhere, and downloaded files are stored somewhere, and so on and so on. We just have to sort of peel apart the how does it all fit together, because there are internal references that needs to be resolved, and it can only be resolved by looking at the binary files, the in-memory database that is dumped to disk. We try to sort of couple the downloaded files that are just given a hashed name, and try to connect that to the real name of the file from the log files. So you have to correlate logs with the downloaded files and the database, and sort of where did this file come from and what was it called on the victim's computer. And then you can start looking for the SSL keys that are used for encrypting data for the beacon traffic. And this can be input to the security people who are looking for connections to the C2 infrastructure. They can actually use the keys to look for connections that are relevant. And of course the bin files, which initially I think was quite a hack. We sort of I think Sindre used Cobalt Strike's own deserialization code to get hold of the data. And then later on, we moved on to a sort of generic way of expanding the bin files. So they are serialized Java objects, and nothing complicated. It's just basic types. They are written to disk periodically, we assume, by the Cobalt Strike server. They contain integer strings and a linked list of those kind of data structures, floats, and so on. And we try to just extract it and create our own objects from this. So here you see the C2 info bin file. This is a typical object that is inside that. It's a list. There's a list of objects that contain the addresses of C2 servers that that is used in this engagement. So you have either a domain name or an IP address there, and which port it's communicating on. And then again, you have the targets bin file, which just lists all the machines that they. Yeah, not to worry. It's the national test of notification system going on. Stay calm.
The police is here.
Yeah. just up against the wall. Sorry. We're done?
Yeah, I think so.
Good. Yeah, so this is a list of all the machines that the attacker has identified inside the victim's network. So basically, this is the pick list for executing new commands. You pick a machine from here, and then, yeah, run whatever you want on that one. And the name of the machine, what kind of OS it has, the IP address internally, and so on. This is a good one. The credentials bin file. Here's a list of all the credentials we've stolen from the victim's network. So it's fair and square list of which host it was stolen from, what's the password or the hashed password, what type of program we extracted, like here, Mimikatz, extracted the password, and what the rearm, like in this case, probably an Active Directory domain, and notes for the attacker. The listeners bin file lists all the external or internal listeners. If you have to, like, if the attacker sort of jumps in through the network and have different hops that it has to traverse to get outside, you have internal listeners, and then eventually you get to the outside listener, which is running on the C2 infrastructure. And here's the different addresses for that. Again, archives.bin. This is like a history of whatever you've been doing. And there's tons of information here. You can see the instructions that have been run, what kind of instruction it is. Here's a task to instructing a beacon to become interactive. Cobalt Strike classifies the actions into MITRE tactics. So you see here is the T1029 tactic, which is a class of activity that MITRE has classified. So we extract that and use that in our reports. Services.bin lists all the services that Cobalt Strike locates and finds inside the victim's network. In this case, a web server running Apache 113. And you have the active sessions list. So here's an active an object that represents an active session from the C2 to a specific machine inside the victim's network. And you can see the operating system and name of the computer and addresses and so on. And it's ready to be interacted with. Yeah. Right. So the Cobalt Strike parser has its own structure, sort of file structure. It produces a runtime log of whatever it's been doing, sort of through the parsing of all these files. And it has a reports folder with PDF, Excel, and CSV reports. It has a folder for the database, and it has also the pure JSON objects that you just saw for processing in other tools. The database is an SQLite database, so it's all like self-contained. You can take this and ship it to, say, police in France, and they can start looking into this. You don't need anything else. You just need the tool and the output folder, and you can start making this into usable police reports. And of course, we produce Excel and CSV files of this format, where you can have a list of all the, in this case, an activity report, activities sorted on time, all the activities that the attacker has done towards a group of machines or a single machine, if you want that. And you can see here all the commands and the results from the commands, the timestamp that it has been run at. We'll mention this a little bit later on. Which beacon it's been running on, the tactics that has been in use, MITRE tactics that it's, and IP address for external or internal machines that have been used in this sort of exchange. Yeah, that too. Yeah, and the name of the computer. Of course, it has an amazing UI that has nobody's seen the likes of. It's very much a practical interface where you have a management interface to, once you load up all these CS folders into it, it sort of stack up. And then this helps you to detect duplicates. Now, why would you have duplicates? Yeah, because these attackers, they are lazy slobs. They copy their data from one server to another. They set up a new VPS and take all their shit along with them. And then they have not just multiple copies of the same folder on multiple servers, but they have multiple versions of Cobalt Strike Parser within the same folder structure, writing on top of the same log file. So you don't know which version of Cobalt Strike the log belongs to. So that's an interesting challenge when you're trying to parse it. And so you can manage all that stuff up in the top one. You can do new extractions, just point it at the new folder, and then on the lower part here, you have the reporting where you can generate whatever reports you want. So simple as that. And then you can generate activity reports like this per IP or per victim. And in this case, you have an interesting column called data over there, where we have sorted now on tasks and spawn commands. And spawn commands are the ones that are interesting because this instructs the victim computer to say, hey, connect to that C2 infrastructure over there. Most of the time it does that. And so here's a way to pick up new C2 servers. You have the IP addresses for the C2 servers right there. So this is something that the security community rarely sees. This is from the C2 server. This is logs from the C2 server. You have to get hold of them. So we, in the Norwegian police, contact the French police or the Belgian police or the Netherlands police, and they go out and grab a server. Because they have the jurisdiction inside their country. And then you get the data, and then you peel it apart, and then you find some new C2s, and then you do it again, and then you do it again, and you stack up this numerous of C2 servers, and you get a wealth of information that you can build your case on. The activity reports also gives you quite a good insight into what's been going on, like what kind of data have they been uploading to the victim's network or downloading. So you can see right above the upload stuff, you can see AD find. That is a clear indication that they've been dumping the Active Directory database. So then we can use the data inside the Active Directory dump to identify the victim, because all the addresses and telephone numbers are there. You can just pick up and call them and say, hey, you're infected.
Those are the fun talks. Hi, I need to talk to your IT manager. I'm calling from the police.
Yeah, you're calling from the police? Yeah, right.
Yeah, right.
Yeah. Then you have reports per IP address. Sometimes it's very interesting to just pick one machine. That's the machine that they've been using for the most interesting tasks. You can just concentrate on that. Other than that, let's see, sessions report. You can see how they've been moving along inside the network. So you can see the patterns that they've been using to spread. And of course, we have something for management as well, PDFs. My favorite format. This gives a quick overview over how many objects have we extracted from a folder, from a set of folders, and also a timeline, so you can see the activity and what type of activities has been happening. And you can see that they've been in there for ages. Most of the time, you can see that they've been inside the victim's network for quite a while before being detected. All the event logs, things that have been happening on the machines or inside the network. Credentials report, which credentials are compromised? How did they start their attack? This can help when trying to identify that. All the screenshots that the attackers have been taking from victims' computer inside their network. Keyloggers. All the stuff that you've been typing on your keyboard as a victim, it comes in this report. The chats that the attackers are having between themselves. There we go. Also breakdowns per IP address inside the victim's network, and again, like timelines and keystroke loggings and chats and so on. So we try to make reports that are useful for the investigators.
So yeah, the PDF and Excel report is fine, but we also would try to do some more visualizations and stuff like that. So, okay, where are the victims? And I think this is like a fairly good show of the spread of this. And the servers were placed in Netherlands and France at some hosting company, and we saw all over the world, except there's nothing in Russia, I think.
Weird.
It's weird, so, and also we had this activity, and when we see the activity over a time period, there's some things if you look start of January, there's nothing happening. If anyone want to guess what time period that is, it's Russian Christmas. There's no activity during the Russian holidays, so.
We're not saying it's Russian.
No, not saying they're Russians or something like that, but we see that. And also when you do take the time zone into consideration, you see when they're doing stuff, it's mostly between 9 to 5 in Russia, or Russia zone. So, and when do they hack? When's the activity? There's a spike on Wednesdays. Well, that's the day they're doing the most stuff. Anyone want to guess why? What happens on Tuesdays? Microsoft patching. So we're assuming oh, there's a patch. Wednesday, we go in and check, do we still have access, or have we lost our access?
Yeah, another issue is when you don't see activities on Saturdays and Sundays. So what does that mean?
You're a company.
You're a government.
Yeah. No overtime.
Yeah.
So yeah, and also we tried Excel is good, but how do you get the overview of what's happening? So we built a graph database as well, and mostly I used that because no one else was bothered with doing that, saying there's too much data. And then we had okay, we were able to get an overview of this is a cluster. You see, we got a lot of C2 servers, we threw everything down, got a mapping of it, and said, okay, we can fairly assume the big cluster is one group, and we had some other clusters okay, we have this data, but they are not communicating at all, so this must be another group. And I was oh, we're investigating 2 actors actually, or 3, because the big cluster is the same guys. Or maybe the same guys. They share they share the stuff all over the place.
Yeah, and on the investigators, they have their own way of sort of structuring the information that we bring to them. So they create something like this. You have the servers here symbolized with the racks. Those are C2 servers that we did get initial hold of. And then inside the red squares are the victims' network. And you can see that how the C2s connect to the different victim networks. And then when we analyze the logs, you get these spawn commands. You extract the IP addresses from the spawn commands and identify new C2 servers, which are then connecting to new victims. So when you seize the new green ones there, the new service that you've identified. Then you expand on this and you identify more victims and you build your network. This isn't the whole picture. This is just a little part of it. It's quite, it sort of hurts the eyes when you look at the whole one.
I think there's like a couple 100,000 victim machines in the data set.
Yeah, you don't want to look at that.
No.
But what you want to look at is the C2s. And when you start looking at the patterns inside here, then some islands emerge. You see the top part of this visualization is separate from the lower part. And this is the first view that we had. Like, we knew these C2 servers. We had logs from these. And then you look at the spawn commands, and you get these servers. And then you go to the French police or the Netherlands police or whatever police, and they help us to seize the other servers. And then you can sort of connect the dots, and you see that these two islands are actually, when you look at the new data that you found when adding all these new servers, all the yellow ones are new ones, and the new connections between this grouping and the other grouping is then revealed. And so what you thought was two groups is actually one. Just collecting all this data helps build the case. But it's tedious work. It takes time to traverse not just the technical side of things, but also the legal side of having the right to go out and seize material. Another way of looking at things is the usernames. We try to group users that are active on the different C2 servers, so we can look at groupings in that way. Now, Cobalt Strike doesn't have any sort of authenticated user concept. You just pick a username when you connect to the server. So if you don't pick a username, you're called Neo. Because that's the default username. So a lot of the time, Neo is Neo's in the top.
Neo is everywhere.
Yeah, but they have their brand. Every one of these hackers have like a cred. They're trying to build cred within their environment, and they use either stems of their names or to sort of be identified inside their own network. So we can use that to group activities. Right, so Q1 2024. This is how it looks now. The Hydro case is more or less sort of wrapped up. We're still arresting people, though, from it. But they lost $78 million. That's the cost of that hack. And Hydro is just one of many.
Yeah. And Hydro did not pay any ransomware.
No.
That's just loss in revenue or rebuilding their infrastructure and stuff like that.
Yeah.
Over time, all that stuff. It costs a lot.
They were very upfront, and they said it from day one, we're not going to pay, we're going to fix this ourselves, and we're going to cooperate with the authorities and try to sort of resolve the issue that way. So from there on, they had a really good cooperation with the police and the security companies to try to sort of get out of the mire. Over 1,800 victims has been identified across 70 countries, and estimated total damages is very hard to estimate this thing, but many $100 million in costs. This is that's the best estimate I have been able to get from investigators. Nobody wants to speculate, but it's like it's downtime and companies going out of business, people losing their jobs, and it's complicated. Hundreds of computers and servers have been seized in the operations. We have found decryption keys for ransomware that has been distributed to victims and helped them to recover the data. Over 50 suspects from these groupings have been identified worldwide. And just to take this, the news stories on the right side here is some pictures are from from 2 rounds of activities in Ukraine during the war. where you're trying to find individuals that are involved in cybercrime worldwide inside a war-ridden country. And it's even more complicated than that because the groups are actually a mix of Russian and Ukrainian people. So you get an interesting group dynamic. And this was something we saw in the middle of the war. Suddenly somebody just turned on their group and sort of betrayed the information, leaked lots of information about their hacking activities. And of course, that's great for us. 15 arrests. I was trying to get an exact number of this, but somebody in the law told me that, yeah, what is an arrest? It's what you call an arrest in one country is not what you call an arrest in another country. So, what we call an arrest in Norway, 15 plus arrests. Switzerland, Ukraine. We're trying to get something from Russia. They're not really talkative. But it's an international effort, and it's still ongoing, and it's gonna go on for a while.
So, Åge mentioned, back to the tool, the timestamps are hard because, at least for the log files, because the binary it's Unix timestamp, UTC, basically. So you just convert it, but the timestamp in the logs are basically month and day. And if you want to find out what year they've done it, you have to go to the folder structure and parse that because that's where you have the year. So basically, when we were trying to get data from the logs, we have to go, okay, what folder is it in? Okay, then it's a 2021 file, and then we have to find the date. And suddenly he updated the program, and then the date format changed. Like, okay, now we need to have another version that also takes this into consideration. And yeah, so it's a mess because the data is not intended to be used the way we do it. So he hasn't done it easy for us.
Yeah, another issue is, I think on the next slide, is daylight saving time. Anyone's guess what's wrong with daylight saving time? If you don't know what country the server is in, what's the problem with daylight saving time?
It changes from country to country.
It's up to the country to decide when they want to have daylight saving time. So you have to be guessing a bit. And also the time zone. Which time zone are you in? Are you actually doing daylight saving time? Is the time correct on the computer? There's a lot of loose variables. And of course, log files can be a mix of different versions. So you have to do this for every file and sort of guess your way through it. And correlate with the timestamps. You find something in a log file that you can correlate with something that has a UTC timestamp in the bin files, and then you can go with the log files, and then they're in sync for a while. Yeah.
And also, the bin files, they change. When new version comes, the data changes. And as we said, the hackers, they tend to go like, oh, new version, let's get it. We need to have it. And they just switch. But they keep the old version running as well. So suddenly you have 4 Cobalt Strike servers running on the same, or team servers running on the same machine. So it's a pain in the ass when we're doing that stuff. So and we have to evolve the parser every time, or not me, Åge has, because I'm not working with it anymore. Yeah. So it's his pain now. And so and also support the older version. So you need to see what type of version is this, and how do you find that? Where is that stored? Yeah, then you have to go to some config files and check this version is that, and then we should run this parser version. So it's a lot to do. So what can we, or as security companies or companies as a whole, what can they do and to contribute with this? Like as we said, if you're breached or you know about some IOCs, share them, because what we've seen, like we have victims sharing data with us, and like we tell them like we don't expect anything. We get the IP and we'll share it with Europol, Interpol, and suddenly down the line, 5 years from now, the FBI might arrest some guy and say, yeah, we found the guy and we found him, and this is the IP, and you can link it back, and suddenly you solve the case years down the line. And by getting those IPs, you can seize some servers, and we will then be able to find new victims and help prevent stuff. And that's the thing as well. Like if you're out on an incident with a customer, or you as a customer, or you as a company get breached, don't be afraid to like report it to the police, because I know there's like people think like, oh no, the police are coming, they're going to take all our servers because we're the victim, they're going to take it and do forensics on it. But no, not going to do that. Don't have the storage space for servers. So yeah, basically just don't be afraid to help the police, like inform the police. It's not that scary. Yes, and on the law enforcement side of things, we can do stuff as well. We can share the IPs that we see from the attacker's infrastructure. In some cases, at least. So that helps the security companies identify malicious activity. We're also looking into MISP, using MISP as a tool to share IOCs from the police. We're currently just listening on MISP, but it's a tool that we want to use to sort of share IPs and information about attackers. Sharing is a little bit complicated, more complicated than I thought initially, but when you think about it, it's not that weird, because some of these attackers are actually using victims' infrastructure to host their C2. And then if we share, like without any sort of vetting of the validity of the IP address and saying this is an evil attacker, and it's actually Microsoft, just the attacker is running something inside Microsoft's network, then Microsoft is going to be really cross with us. Yeah, so it's complicated. But we can inform security companies and the public about these things and make sure that awareness about the cost of being infected and to letting people use your infrastructure to infect others. That has a significant cost on a global basis. And also awareness about how to handle incidents, how to report. As like Sindre says, don't be afraid to report. Somebody thinks that when you make a report, you notify the police. It's going to be a big process. Now, maybe there's not going to be a big process because they just note the information and it becomes part of the statistics, which they later on use to get funding for further work within the field. And nothing's going to be done on your case. But later on, we're actually going to have focus on this type of incidents. So just having a sort of measure of the scale of the problem is useful for the police. If it's all in the dark, we don't know how much effort to put in on these things. So report. And we will continue to support the international investigation efforts, because this is like a huge economic problem. The amount of money that goes down the drain or goes to organized crime through these channels is immense. And the kind of other activities that these organizations are linked to, it's trafficking, it's drugs, it's you name it. They're into all sorts of things, these gangs. And this is
the organized crime scene is very business driven.
There's a large map as well of all the crypto transactions and how that network is built with mules, people just getting something, sending to mixing services. Like that's a huge map as well, trying to find the people, and they make some mistakes down the line. They all do. So yeah.
Yep.
Questions, anyone? Yes.
Yes, I have 3 questions actually.
Yeah.
The first is what kind of help, if any, did you get from the vendor of CS? Second is based on the statistics that you presented, the target victim statistics. Did you draw any conclusions? Is there more gullible countries, organizations, private versus state operating systems and such? And the last question is, you mentioned chats. Were they actually using the CS to communicate?
Okay, so yeah, question number 1. Did we get any help from the Cobalt Strike guy? No. I sent him a mail asking if it was okay for like breach of policy stuff. Like, is it okay for you that I use your code to build my own tool for the police? Like, and he didn't reply. So we don't know anything. Never talked with him.
They have quite a hard vetting procedure for buying Cobalt Strike. You can't be a criminal and you can't be law enforcement. It's sort of grouping those two together. So
we were like thinking, okay, can we get a legal version to test this? Or no, we couldn't because we were law enforcement. Okay, then we have to test and build this, the program using the criminal's cracked version. That's the way we could do it.
So it's hard to test when you don't have really something to test with.
Not fetching, just they give you some specs or insights into the format.
Yeah, no, nothing. We could find something because it was he has reused some code from Metasploit Armitage into Cobalt Strike. So there's some similarities there. So, and the second question was statistics and companies and victims and stuff like that. Basically, it was all over the world. And we saw like the infected machines, they found, okay, what is this? And then we saw like a note, they wrote down, okay, 10,000 computers, school. And then nothing more happened or something happened. And small company, 4 PCs, or whatever. Like they noted, okay, what's the network like? Yeah. And we saw there's no Russian or like Russian-speaking countries in the list of infected machines.
There might be a pattern to the governmental also the APT side of things. But these people, they seem to be organized in a sort of a chain of prioritizing. Somebody is just working on getting access. It doesn't matter who you get access to. You just claim access and secure it. And then you pass it on down the line to somebody who's trying to develop that foothold into something else, trying to expand and do research. And if they have a lot of things to do, then it's naturally going to prioritize bigger targets and so on. But even small targets can be focused on if they have the time. And then they go on to exfiltrate data. And then once you have the data, what kind of data is it? How can we monetize it? Can we extort people based on what they have for data? Or should we just ransomware encrypt them? Yeah, it all depends.
And the third, about the chat. Yes, they used Cobalt Strike chat functionality. So basically, they were talking to each other, and you saw they used like Cyrillic keyboard when they were in the chat. And sometimes they forgot to switch back to English when they were in doing commands on PCs. So like, why doesn't this command work? Why doesn't this command work? So they like did it multiple times before they saw, oh yeah, I've written it in Russian. So yeah, then you see like, oh, switch keyboard, and then it works. And you also see like, when they get into a machine, you see like, okay, basically they've gone into a notepad, copy paste, copy paste, copy paste. Basically they just run command down the line, because we saw like there's a pattern. They do the same thing every time they get a new machine. And basically if it doesn't work, do it again, do it again, do it again. It's noisy as, I don't understand how people don't detect it, because it's so noisy, and they don't care in the initial phase, like, or like this group, they're like, we'll do everything. Mimikatz do everything, like make a lot of noise, and they didn't get caught. And if they got caught and booted up, just go
on
down
to the next one.
On to the next one, because there's 100,000 machines here. Let's just take the next one. Yeah. Any more questions?
Yep.
Did you share the tool you created on the law enforcement, or is it open source? Or?
Yes, it's in Europol's tool chest. I don't know what they call it, but it's right now it's like in 4 or 5 countries in the code base, developing or submitting patches, integrating it with other tools and so on. And we see that this tool is going to stay relevant for quite a while. As long as Cobalt Strike is, you're able to use it, it's going to be relevant. And of course, new tools pop up, and then we need a tool for that as well to sort of extract the logs from that. But this kind of investigation technique, where you identify the C2 infrastructure, grab it, analyze it, repeat, and then try to go for identifying the criminals from way they communicate, how they work together. This is the way to go. And also, like if, I don't know if people were on the Troy Hunt the session earlier, where he said that criminals, they do mistakes early on in their career. This is what we see as well. If you were to just have like a time slot from the newest information, then you would have a hard time to identify some of these guys. But if you go back in time, you can get the information from the days where they weren't experienced and weren't focused on OPSEC and weren't doing things properly. And then you sort of hook them that way.
Do you find that like threat actors in non-extradition countries are like not giving a shit about OPSEC? And if you're using stuff like, you know, Impact and Cobalt Strike, and basically tools that you pirated that are one click, here, click this, you know, Battlefield 2 executable, it's just a crack game, go for it. And then you can infect anyone without, you know, with Windows firewall disabled.
I think they are still focused on their personal OPSEC. Maybe they're noisy and OPSEC on the sort of operational side of thing for what they're doing is lousy. But for the personal side of things, they don't want to be tied to a person. Still, if you're in like sitting in North Korea hacking away, you don't want to be known by your real name. So it's two sides of that.
It's like their OPSEC is good until they log into the team server on like and then when they start working on the victims, they don't care. They just run around. And so basically they're personal OPSEC good, but organizational OPSEC no.
There's no effort to hide that you're a state actor. Like,
No.
It doesn't matter.
No.
Well, this is just from what I've heard, the line between a government actor and a non-government actor in some countries is very much a gray area.
They're not state sanctioned maybe, but they're also like, you know, we're just chilling in St. Petersburg, no one's bothering us doing this, it's fine.
Yeah. Could be. Anyone else?
Think
Nope. It's time for coffee.
lunch.